Assalamualaikum warahmatullahi wabarakatuh. Our MAT210 group project is going to take the tic-tac-toe as our group project. So I will explain for the introductions. For introductions, logical reasoning is a key cognitive skills that allows individuals to process information, draw conclusions, and make decisions based on evidence and structured thought. In the context of games, logical reasoning is crucial in understanding the rules, anticipating moves, and executing strategies. Board games, particularly simple ones like tic-tac-toe, offer an excellent platform for studying logical thinking because of their clear structure and finite set of moves. This game often requires players to think several steps ahead, recognize patterns, and apply specified strategies to win or force a draw. So, how players win this game? So, tic-tac-toe, also known as a nouns and crows, is a two-player game that takes place on 3x3 grid. The objective is to get a tree of 1 marks either X or O in a row or column or a diagonal while preventing the opponent from doing the same. Despite its apparent simplicity, tic-tac-toe provides an excellent opportunity to explore fundamental concepts of logical reasoning such as pattern recognition, decision making, and strategic planning. So I will pass to HAMIZAN to explain about the concept.
Next, I will continue this discussion with logical concept in tic-tac-toe. First, pattern and possibilities. Tic-tac-toe operates on 3x3 grids, which has a finite number of possible moves and winning combinations. Logical reasoning involves recognizing these patterns such as rows, columns, diagonals, where a player could potentially win. Next, minimax algorithm in advanced strategy. In more advanced version of tic-tac-toe or in competitive play, the minimax algorithm is used to minimize the possibility loss and maximize the player's advantage by evaluating possible future moves. Other than that, decision tree. Each move in tic-tac-toe creates a branching possibility for future moves. Logical reasoning involves looking at the entire game tree and analyzing the consequence of each move. Lastly, game theory. The concept of net equilibrium, where each player makes the best decision considering the opponent's strategies can be applied to tic-tac-toe.
For now, I'm going to explain about the application in tic-tac-toe games. There are 3 applications that we can use to win the game. First, blocking opponent's winning moves. One of the simplest forms of the logical reasoning is to block an opponent's move if they are one step away from winning. Secondly, creating winning opportunities. Players also think ahead to create 2 potential ways to win, forcing the opponent to block one and leaving the other open. Third, forcing moves. A good strategy involves forcing the opponent into making decisions that are not advantageous, manipulating the game flow through logical deduction. So, I'm gonna give you explanation from this truth table. If P then Q. This is true in all cases except when P is true and Q is false. Secondly, not P or Q. This is true when either P is false, which makes not P is true, or Q is true. So, the logical equivalence from the truth table, you can see that the column for P implement Q and not P or Q are identical in all cases, which show that these 2 expressions are logically equivalent. In summary, the truth table confirms that P implement Q and not P or Q are logically equivalent because their true values match in all possible cases.
So for now, I will explain to you about logical equivalence, how it's connected in tic-tac-toe games by using the strategy in tic-tac-toe. So, connecting logical equivalence with tic-tac-toe. In tic-tac-toe, the goal is to get 3 of your marks S or O in a row, column or diagonal, while blocking your opponent from doing the same. Each move can be considered as a logical proposition or condition where you make these decisions based on what is true or false at any given point in the game. For simplicity, let's consider 2 propositions. The first one is P. P is there is an empty space in the current row or column or diagonal. Then Q, the player can place their mark in that space. In this case, when P implement Q, if there is an empty space, the player can place their mark in that space. So they can represent a basic strategy. In other words, if a space is empty, so P is true. The player has the option to place their mark in that space, so the Q is true. This is a simple true to game logical condition. So I will explain to you the truth table. So the truth table shows that P is empty space, which is there are 2 variables T and F, and Q can place mark. P implement Q if P, then Q, not P, space not empty, not P or Q, then they will show the equivalence of the table. Then logical equivalence in tic-tac-toe strategy, we can now apply logical equivalence using P implement Q and not P or Q. When P implement Q, it explains if there is an empty space P, the player can place their mark Q. For not P or Q, either the space is not empty, not Q, not P, or the player can place their mark in the space, it is Q. These 2 propositions are logically equivalent because in tic-tac-toe, both conditions ultimately reflect the same underlying strategy. If a space is empty, then P is true. The player can place their mark Q is true. This leads to the same conclusion as either the space is not empty or the player can place their mark. So, in both cases, the truth value of the expressions will be the same. That means either both true or both false. Then, when P is empty spaces, it represents whether there is an empty spaces where a mark can be placed. Q can place marks. It represents whether the player can place their mark in that space. P implement Q. If P then Q, this statement is true when there is an empty space and the player can place a mark there. not P, space is not empty. The negation of P represents whether the space is not empty. For example, the space is taken by either player's mark. So for not P or Q, this is true when either the space is not empty or the player can place a mark in the space.
So for now, I'm going to explain about the summary. Logical reasoning and equivalence play a vital role in understanding and strategizing in board games like tic-tac-toe. By analyzing game moves using logical proposition, players can make rational decisions to secure a win or block their opponent. Logical equivalence such as P implement Q, if there is an empty space, the player can place a mark, and not P or Q, either the space is not empty or the player can place a mark, highlight the consistency in decision making. Using the truth tables, we demonstrate that these two statements yield identical results in all scenarios, showing their logical equivalence. This principle helps players recognize patterns, anticipate moves, and strategize effectively during gameplay. Logical reasoning in tic-tac-toe not only enhances understanding of the game, but also sharpens problem-solving skills applicable to more complex scenarios. Table, you can see that the columns for P ni apa lah? Implement
Assalamualaikum warahmatullahi wabarakatuh. Then I will explain to you the truth table. So the truth table shows that P as a E. Then logical equivalence in tic-tac-toe games when we use strategy in tic-tac-toe. Mana asal
Signals where a player could potentially next, minimax algorithm. Minimax.